Okay, we're going to go ahead and look at the Unit 4 review for Part 1. And in just a minute, I'll flip it over. We're going to start by looking at Side 2. And we're going to look at our select all. So, some people are logging on. Hey, how are you? So when I look at my Unit 4 review on Side 2, this question that we're going to start looking at, it says select all the equations that have a value of 7/4. So first of all, I know that I'm looking for 7/4 or 1 3/4 because these are equivalent. This is as an improper, and this is it as a mixed number. Alright guys, it's like balancing on my document camera, so that's why it's kind of wiggly. So the very first one says 3/2 plus 4/2. So I'm going to go onto a sheet of paper. Well, actually, since the denominators are alike, I can add it over here without really showing much work. The denominator would stay the same, and I would add 3 plus 4 is 7. Does A work? The answer is no. A will not work because I don't want 7/2. I want 7/4. So then I'll move on to B. B is 1 3/6. I'm going to write this on a separate sheet of paper so I have room to work it out. 1 3/6 plus 2/8. So I need to find a common denominator for 6 and 8. So I'm going to go ahead and start out by listing my multiples for 6, my multiples for 8. So my multiples for 6, I have 6, 12, 18, 24. Multiples for 8, I have 8, 16, and 24. So I want to find that least common multiple to create my least common denominator. So I have an 8. Do I have an 8? I have a 16. Right, so the least common multiple is 24. Foreman! No, don't throw that away, please. No, the kids stuck it over there. Thank you. Yeah, right? Save my life for the paper. So I want to create a common denominator of 24. Common denominator of 24. So I want to figure out what am I going to do to go from 6 to 24. And I'm going to multiply 6 times 4. And what I do to the bottom, I'm also going to do to the top. So multiply your numerator by 4 as well. And you get 12. Here I want to figure out what did I do to go from 8 to 24.
Nope. Nope.
I multiply times 3. So what I do to the bottom, I'm also going to do to the top. And I get an equivalent numerator of 6. So now take a minute, add them up. You get 1 and 18 24ths. So I guess I need to figure out, is that going to equal 3/4 because I want my answer to equal 1 3/4. So could I get that to equal 1 3/4? Let's see. 18 divided by what is 3? Divided by 6. And will that work with my denominator as well? Yes, it will. So A does not work, but B does work. Look at C, 14/12 minus 7/12. No, minus 7/8. 14/12 minus 7/8. Okay, by looking at it, I should be able to tell that it's not going to work because I need it to equal 1 3/4, and here I barely even have over a whole. However, in the interest of just solving it, I'll go ahead and do that. List my multiples for 12, my multiples for 8. So I've got 12, 24, 36, and I have 8, 16, 24. So my least common multiple is going to be 24. So I'm going to make them equivalent with denominators of 24. What did I do to go from 12 to 24? Times 2. What I do to the bottom, I'm also going to do to the top. I'd get 28. What did I do to go from 8 to 24? Times 3. What did I do to the bottom, I'm also going to do to the top. So 7 times 3 is 21. So when you subtract 28 minus 21, you get 7/24. So is letter C going to work? Right, C will not work. So let's now try D. When I look at D, D is 4 3/10 minus 11/20. So 4 3/10 minus 2 11/20. So what's your common denominator going to be? Oof, that's all blurry. There we go. All right, our denominator is going to be 20, but again, if you didn't know it, you would list your multiples for 10 and list your multiples for 20. I'm going to rewrite them with a denominator of 20. This one's already in 20, so I could just bring it straight across. Here, what did I do to go from 10 to 20? Times 2. So what you do to the bottom, you're also going to do to the top. And you get an equivalent numerator of 6. 6 minus 11. Right, I can't do 6 minus 11, so I have to borrow from my whole, and my 4 will become a 3. So what is 1 whole? How many 20ths am I going to add to equal 1 whole? Right, 20 20ths. Whatever your denominator is how much you're adding in. So you have 6 plus 20, now you're going to do 26. You had 6 and then you added in your 1 whole from regrouping. So 26 minus 11. 15 20ths. And then 3 whole minus 1 whole. Or sorry, 3 whole minus 2 whole is 1. So again, I want to figure out, is this going to equal my 1 3/4? Could I go from 15 to 3? What could I divide by? Divide by 5. So can I divide 20 divided by 5 and equal 4? Yes. So since I can divide 15 divided by 5 equals 3 and 20 divided by 5 equals 4, this does equal 1 3/4. So D does work as well. And let's look at our last one for this question, E. E says 1 1/8 minus 9/16. So what would be your common denominator? Right, your common denominator would be 16, but if you didn't know it, again, list your multiples and find your least common denominator. This one's already in 16, so I'm just going to bring it across. What did I do to go from 8 to 16? Times 2. Times 2. 2 minus 9. Can't do that, so I'm going to borrow from my whole. And that becomes a 0. And add in 16/16. So if I add in my 1 whole plus the 2/16 that I already have, now I have 18. 18/16 minus 9/16 equals 9/16. So does E work? Nope. E does not work. So you ended up with two that worked, which was good. Now I'm going to move on to my next question. My next question is going to be down here at the bottom. We're going to look at this line plot. So before we even really look at it, I want us to figure out what interval, what unit fraction is our line plot divided into. So the way you can find that out is you can count how many hops there is from 1 whole to the next whole number, and you don't count the one you start on. So it'd be 1 hop, 2 hops, 3 hops, 4 hops. So our number line is divided into fourths. So this would be like 21 1/4, 2 fourths, 3 fourths, and then 4 fourths is your next whole kind of thing. And then again, 22 1/4, 22 2 fourths, 22 3 fourths, and so on all the way across. So let's look at these questions. This one says 2 more ribbons are added to the line plot above. How the total length of 200 and to have a total length of, now the total length is 200 inches. What are the 2 possible lengths of the added ribbon? So it's telling me a new total is going to be this. So in order to figure that out, first I need to find the original total. So I have to actually add up all the values on that line plot. So it's going to be a lot of work. No joke, but it's worth it to get the question correct. So I want you to figure out what is the value of this 1 point. Right, the first one is at 22 and 1/4 plus, no, sorry, 21 and 1/4 plus 21 and 2/4, but I need to add that twice, plus 1/4, 2/4, 22 and 2/4, and I'm going to have 2 of those. So 22 and 2/4, and then plus 22 and 2/4 again, plus 23 and 1/4, and then 1/4, 2/4, 3/4, 23 and 3/4. So I'm just going to make sure that I got all my data points represented. So I'm going to count my line plot. I have 1, 2, 3, 4, 5, 6, 7. Do I have 7 numbers? 1, 2, 3, 4, 5, 6, 7. Perfect. So first thing I'm going to do is start out by just adding my fractions. So 1 plus 2 is 3. 3 plus 2 more is 5. Just put a little 5 there. And then 5 plus 2 more is 7. 7 plus 2 more is 9. 9 plus 1 is 10. And 10 plus 3 is 13. I'm going to go back and double check just to make sure that I added those correctly. It's way worth it to get it right. So 1 plus 2 is 3. Plus 2 more is 5. Plus 2 is 7. Plus 2 is 9. Plus 1 is 10. Plus 3, yes. So 13/4 worked, no problem. Now I could add chunks at a time. So I could say this is 5. 2, 2 and 1 is another 5, plus 3, 5 plus 5 plus 3 is also 13. So it doesn't matter how you do it. Those whole numbers, there's quite a bit of them. So I think I'm going to rewrite them going up and down. 21 plus 21 plus 21 again. Make sure my place values line up. Plus 22 plus 22 plus 23 plus 23, and again I'm going to make sure I have all 7 whole numbers because there were 7 points on my line. So 1, 2, 3, 4, 5, 6, 7, got them all. So now I'm just going to add up my whole numbers. 1 plus 1 plus 1 is 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So drop down my 3. Regroup my 1, 2, 4, 6, 8, 10, 12, 14, plus 1 is 15. 153. So I'm going to just check that again just to make sure I got it right. 1, 2, 3, 5, 7, 10, 13, good. 2, 4, 6, 8, 10, 12, 14, and 15. Yep. Okay, so 153. Now, I should notice that I cannot have an improper with a mixed, so I have to regroup. How many times can 13 go into 4? Or how many times can 4 go to 13? Think about it as division. I know that 4 times 3 would mean I'd take 12 away to give me 3 new whole. So now I'd have 156 and 1/4. So the total of the line is 156 and 1/4. But it says in the word problem, it says the new total is 200. So I want to take 200 and subtract. So take the new total and subtract my old. My old total was 156 and 1/4. So if I want to find, I'm going to find the difference between the new total and the old total. So I have to be able to subtract that fourth, so I need to borrow from here. If I borrow 1 from 200, now I have 199. And 4/4, because 4/4 is my 1 whole. So 4/4 minus 1/4 is 3/4. 9 minus 6 is 3. And then 9 minus 5 is 4. So this is the difference between my new total of 200 from the word problem and my old total. Oh, what am I eating? You're going to love when I tell you what I'm eating. You're not going to like this, actually. I don't even know how you know I was eating something, but clearly I'm being annoying with my eating. That's what I'm eating. Alright, so anyways. What up? So after I find the total from my old line plot, and the word problem says this is the new total, and it says 2 more ribbons were added to give me this. So it means 2 more data points added together to equal the difference of the old one minus the new one. 2 more points were added on there that is going to equal this. So I need to find 2 fractions that can add together to equal 43 and 3/4. So now what I need to do is I just need to take 2 and try to add them together to equal a total of 43 and 3/4. So first of all, 2 fractions that could add together to give me 3/4. Let's see. I can't do, let's see, 1/2 is actually equal to 3/4. I know, 1/2 is equal to 2/4, so that's silly of me. 1/2 equals 2/4. This one's already in fourths. I can't add a fraction to 3/4 to give me 3/4, so I'm just going to scratch that one out altogether. So I know that a 1/4 and a 2/4 will give me, a 1/4 and a 2/4 is what's going to give me 3/4. So this one has to be used because in fact this is the only one that has a value of 2/4. So I want to figure out what am I going to add to 21 and 2/4 to give me that. So 21 and 2/4. If I subtract that, it will tell me what the other fraction has to be. So 3/4 minus 2/4, we already knew it had to be a 1/4 because the 1/4 and 2/4 is what's giving me that 3/4. And then 3 minus 1 is 2. 4 minus, so I need one that is 22 and 1/4. 22 and 1/4. So in other words, if I add together 22 and 1/4 and 21 and 1/2, they're actually going to equal the difference between the old total and the new total. I recommend that if you did not completely understand this, because this is on your test, that you kind of go back and just try to rewatch. But again, when I added the total of the old line plot, when I added the total of all 7 of these points, it ended up equaling 156 and 1/4. The word problem says the new total is 200. So when I subtracted those, I had to borrow 199 and 4/4. I got a difference of 43 and 3/4. This point and this point add together to equal that, because again it said 2 points were added. This point and this point were added together to give you that new total of 200. Okay, and let's look at the other one. This one is very easy, so this will be quick. It says what is the difference between the greatest point and the least point. So I need to find my greatest point and my least point. 2 options. A, you can subtract it. So I could say this is 23 and 1/4, 2/4, 3/4, 23 and 3/4. Minus 21 and 1/4. And you can easily subtract these. I mean, these are not hard fractions to subtract. 3 minus 1 is 2/4. And then 23 minus 21 is 2. So you can get a difference of 2 and 2/4. 2 and 2/4. Oh, you know, I don't see 2 and 2/4. So what do I know about 2/4? 2/4 is equal to 22 and 1/2. So now you can see that answer is A. The other choice is that if you weren't good with subtraction, you could actually count your intervals. 1/4, 2/4, 3/4, 4/4 is 1 whole, so 1. 1/4, 2/4, 3/4, 4/4 is 2 whole. 2 and 1/4, 2 and 2/4. And again, we got 2 and 2/4 here, and we said that's equal to 1/2. So you can either count your intervals, or you can subtract your greatest minus your least. That's all I'm going to go over for tonight, unless anybody has any specific questions. This is so confusing. Okay, who wants help? I just heard somebody say this is so confusing. See to my snack till I'm waiting for comments. Well, lucky you, you did not get homework. We're getting ready for our test, because we're going to rock it. We're going to have the best scores. You're good now, huh? Alright, well, I'm going to sign out for the night. But if you need anything, you can always let me know. You can always go back and stop doing that, please. Stop doing what? Stop eating these? These are delicious. But anyways, if you need anything, go back, rewatch the videos, rewind to the parts you need help with, and there's also a couple older videos of this same sheet from last year that you can look back as well. That's all for tonight. I'll see you guys tomorrow.